Good morning to all. I am Dr. J. Arul Raj, Assistant Professor of Botany, CPA College, Bodinayakanur. Let's we go to start about topic isomerism. Definition: the compounds having same molecular formula but different physical and chemical properties are called isomers, and the phenomenon is called isomerism. So we are having many compounds or exposed isomers, and its property is called isomerism. Isomers means, so some compounds are having same chemical formula but they are having to expose as a different chemical formula, chemical structure or chemical configuration, that is called isomers. The term isomer was first introduced by Berlioz in 1827. Iso means equal, meros means part. For example, glucose, fructose, galactose, both are having, all are having same chemical formula, but it is going to exposed as a different chemical configuration or structure. So these compounds have same chemical formula but different structural formulas. Hence they are called isomers. Am I correct? So all are having same chemical formula but they are going to source to as different chemical structure or chemical configuration. The isomers contain the same numbers of the same kinds of atoms, but the atoms are attached to one another in different ways. Isomers are different compounds because they have different molecular structure. Am I correct? So all are having same chemical formula and its compounds also are having same number of atoms. For example, C6H12O6. So this is same chemical formula of monosaccharides such as glucose, fructose and galactose, but all are different molecular structure. Am I correct? So isomerism is a property of all compounds having asymmetric carbon atoms. So these are compounds which are having asymmetric carbon atom. So isomerism is exhibited by many compounds such as carbohydrates, amino acids and fatty acids. So these are having isomeric properties. So carbohydrate of isomers, glucose, galactose, fructose. So all are having same chemical formula. It shows to us different chemical configuration. Glucose. So this figure clearly shows to us glucose, galactose and fructose. All are having same chemical formula, but they are exposed to as different chemical configuration. Types of isomerism. Based on the difference in arrangement of atoms, isomerism is classified into two types, namely structural isomerism. Second one is stereoisomerism. So, isomerism, it, it can be classified into two types, stereoisomerism and stereoisomerism. So this table shows us kinds of isomerism. So structural isomerism, another one is stereoisomerism. Structural isomerism, which can be divided into four types: chain isomerism, position isomerism, functional group isomerism, metamerism. So whereas stereoisomerism, it further classified into geometrical isomerism, another one is optical isomerism. First, we are going to see about what is structural isomerism. When different compounds having the same molecular formula possesses different structures, the phenomenon is called structural isomerism. That means, so all compounds are sourced as different chemical structure or chemical configuration, but all are having same chemical formula. Am I correct? So the compounds are called structural isomers. The structural isomerism arises from the difference in the arrangement of atoms within the molecule. Am I correct? Thus, the structural isomers have same chemical formula or molecular formula but different structure. we have to see again glucose, galactose, fructose. So all are having chemical formula, but the position of atoms or elements within the compounds are totally different to one another. So that is called structural isomerism. Here, glucose, which are having carboaldehyde and primary alcoholic group CH2OH. So whereas fructose at second carbon position there is presence of ketone group. Am I correct? Here glucose and galactose both are having same chemical formula but totally different to one another based on their structure. Here, hydroxy group at fourth carbon position of glucose which is possessed at right side, whereas galactose hydroxy group at fourth carbon position which is possessed at left side. So this is uh, different to this is structure different to one another. So that's why this is one kind of structural isomerism. Another one is based on the linking of atoms. Structural isomerism is classified into the following three types: chain isomerism, position isomerism, another one is functional isomerism. Okay. Next, geoisomerism. So the same molecular formula differ in relative arrangement of atoms in space within the molecule and the compounds are called stereoisomers. Okay, thank you.